Hi, I am Krishnamurthy. I am working as an assistant professor, mechanical department in ENGG.COLLEGE. Today I am going to take the class about the stream of manufacturing engineering. My topic is metrology and measurement. First things I like to introduction what is metrology, what is measurement. So what is metrology? Metrology is nothing. Scientifically we are studied about the dimensions. What is measurement? This measurement is nothing, the physical quantity which we are going to measure. The topic to be covered in this section is, first thing is limit, fits and odds and shaft basis systems tolerance. First, before we are going to see what is metrology and measurement system, what happened that we need to know that what is hole and shaft basis system. In industries, every component is manufacturing based on this system only. What is hole and what is shaft? Everybody know that hole and shaft. So let us see what is hole system, what is shaft system. Okay, the old system, if we are consider the old dimension is constant, then shaft dimensions vary, it is old systems. If you take a hole like this is a shaft. In assembling unit, what we are doing, we are going to assemble the shaft into the hole. So for that we are giving some tolerance. Here this dimension is constant. This dimension will be very depend upon the types of fits. This is old system. So next one is a shaft system. Here shaft the same, but in this the dimension of shaft will not change. Instead of that, the dimension of hole will be changed. This is the basic principle of hole and shaft basis system. This is the basics how to find out the fits in assembly. The first one is hole basis system, second one is shaft basis systems. There are three fits is widely being used in industry by the design peoples. First thing is clearance, transition, interference fit. Here let us see this clearly. Here the whole dimension is constant. The shaft dimension is varies depend upon the fits. The next here the shaft basis system, we can see here clearly what happened. The shaft dimension is constant. The whole dimension will be vary for depend upon our fit systems. What is fits? Fits is a very important in manufacturing. Even though we are manufacturing the good quality of component, finally we are going to assemble it. That's a very important. So any product, it is not it's made up of single unit. It is a combine of the different parts. So we need to assemble or make all the components exactly what our requirement. Here, so there are three types of fits so widely used. One is a clearance fit, another one is interference fit and transit fits. This is for the different applications this type of fits are used. Okay, first is what is clearance fit. Let us see. There is one hole and shaft. Okay, when the shaft is move or slide into the hole, if this shaft is moving into the hole without any struggle or obstacle, okay, it is moving into the hole, it is called clearance fit. These are fits of used for just like we are just hold the shaft into the shaft is hold into the shaft in the cylinder or in the hole. Example of clearance fit. The clearance fit is widely used for the parts of bearing, pushing and other the components where this hole and shaft is not tightly fit. The interference fit. What is the interference fit? There is the opposite of the clearance fit, we can see this hole and shaft. So if we want to shaft, you have to fit into hole, we need some pressure to push the shaft into the hole, or it is called as the pressure fit. Example of interference fit for gear and shaft. So usually gear and shaft is connected by this type of interference fit only. Next one is a transition fit. Transition fit is this is between the two. It is lies between the hole and shaft. Here we can see, we can get it two fits in a transition fit. First one is interference fit and the clearance fit. Best example is pen. When you have to remove the cap, okay, when you have to put the cap in the pen, this is the one of the transition fit. What will happen in a transition fit? The size of the cap, okay, less than the size of the pen. But when you have to insert that, what will happen? The size of the cap will be enlarged. Okay, this is the one type of transition fit. So example, this pen, okay, just the cap. When you have to insert the cap, we are getting the transition fit. Next one is a tolerance. The tolerance is a very important elements in metrology and measurement. Without tolerance, we cannot manufacturing any component. First thing is, what is tolerance? The tolerance is nothing. If you want to manufacturing 10 mm diameter, no one can manufacturing 10 mm diameter exactly. So just we are giving this the manufacturing peoples as a relaxation. Okay, that relaxation is designed by the design people. We should know what is relaxation which is given to the design manufacturing people by the design peoples. Here the tolerance is the limit, the minimum and maximum limit of any component. It is called tolerance. Okay, what is limit? First thing is we know what is limit, then we are go to tolerance. Here classification of tolerance. The tolerance can be classified in 4 types. One is unilateral tolerance, bilateral tolerance, compound tolerance, geometrical tolerance. Before we are going to discuss this, we should know what is limits. As I told here, so what is limit? First we see what is limit. Let us see what is limit. So now, if we want manufacturing 40 mm of diameter of shaft, this dimension is, what is 40 mm? Okay, this is a base dimension or basic values. Okay, the 40 mm, surely no one can manufacturing this shaft exactly 40 mm. So the design people, they must give some of relaxation to the manufacturing people. That is called limit. There are 2 types of limits. One is upper limit and lower limit. Now example, 40 mm, just I give the relaxation to the manufacturing people. So plus or minus 0.02 mm. What is the meaning? That this is a limit. What is this? Is a limit. The manufacturer people can be manufacturing the component between 39.98 or 40.02 mm. This is the limits which we give the this amount of values give the manufacturer people as their relaxation. They can manufacturing from 39.98 mm to 40.02 mm. This is a limit. Okay. Next, tolerance. As we are discussed before, there are 4 types of tolerance: unilateral tolerance, bilateral tolerance, and compound tolerance, geometrical tolerance. As we are seeing this here, what is unilateral tolerance? Unilateral tolerance means the values which is given to the limit to the component is only in the positive, not in negative. Example, this is a 40 mm. This is a 40 mm basic size. If I give the values only plus 0.02 plus 0.05 4. That is the lower limit and the upper limit in only the positive direction. This is a unilateral tolerance similar to this 40 minus 0.02, sorry 4, 0.02. This is also unilateral tolerance only in the negative side. Okay, next is what is bilateral tolerance. The bilateral tolerance means the values can be given in both positive as well as the negative direction. Example, now the 40 plus or minus 0.0. This is the plus or minus means what? Okay, the 40 minus 0.02 plus 0.02. Like this is what is bilateral tolerance. So next one is example for unilateral tolerance. We can see the shaft which to be manufacturing the 40 mm diameter. For this the limit is given. The first is what is 40 plus 0.01. Next one is plus 0.02 in a unilateral tolerance, as here 40 minus 0.02 minus 0.01. This is a unilateral direction because the values which is given in a one direction only positive or negative only. So next one is an example of bilateral tolerance. We can see the values plus or minus 0.02. Similar here, the values in the minus as well as the plus. This is the bilateral tolerance. Next, the compound tolerance is somewhat difficult. Most of times the manufacturing people avoid this type of tolerance method. Here, what we are going to do, we are going to find out the tolerance of R. If we want to know the tolerance of R, we need to consider the remaining values like 40, 20, 60. This is a 20, this is a 20. Those things are we have to consider to set the R value or determine the R value. This is type of method is called tolerance, compound tolerance. Next one is a geometrical tolerance. Another is very important in the geometrical tolerance, the assembling section. When you are going to assemble the two parts, usually what we are doing in a geometrical flatness, perpendicularity, center is like very important elements when we are going to assemble the two parts. If you want to assemble the two shaft, what we are doing, should consider the center of both components should be in a line. It is one of the geometrical tolerance. Let us see that here a list of geometrical tolerance. First is the straightness dimension. This is a symbol of this. Always we can see this in a blueprint of the any component which is provided by the design people. Straightness, then circularity, flatness dimension, cylindricity dimensions, profile of line of dimensions, profile of surface 2 dimensions. So next one is a perpendicular. Okay, already you know that what is the symbol of the perpendicular. Then parallelism, angularity, and the position of dimension, concentricity, circular runout, and total runout. So geometrical tolerance, here we can see what is geometrical tolerance. We can able to see this type of the printer on the image. Here this one is. Okay, this is a tolerance given by the design people. What is this? This is a concentricity. What should be this? Pi 0.01. This is the way to provide the tolerance to the tolerance in a geometrical tolerance. Next one is a maximum and minimum metal condition. What is a maximum metal? Minimum metal is nothing. Okay, we can see this. This is a hole. This is a shaft. Okay, this is the limits. This is the limit of the hole. This is the limit of the shaft. Okay, the maximum. What is means in the maximum limit in the hole means this. Maximum limit in the hole is this. Okay, minimum limit is this. Similar to this, the shaft, the maximum limit is outer surface. Then the lower limit is called least metal limit. So next one is a progressive dimension. Progressive dimension is another important progressive dimension in manufacturing. Here, what we are doing here, there are three components A, B, C, D. If we want to know this, the dimension of overall, this is what is this. Okay, first this B dimension 30. This is a bilateral tolerance. C also bilateral tolerance. That is overall dimension also given as a bilateral tolerance. If you want to know this A or if you want to know this overall dimensions, where see here, first thing is we need to have the whole upper limits. Here look, 0.02, 0.02, 0.2, total is 0.06 mm. The cumulative lower limit is 0.01. This one is 0.01, 0.01, 0.0. Total is minus 0.03. The total limit of this, upper limit, lower limit is 60. Lower limit is minus 0.03, upper limit is 0.06. This way we are going to give the limits to in the progressive dimension. So next one is, let us see the problems. The most of problems are sometimes asked in the gate examination also. Here the first, okay, let us see. First question is, the hole is a diameter of 9 mm. The limit is, what is 0, lower limit, the upper limit is 0.015 mm. Okay, this one is what is hole. That is minded. This is very important. The hole is 9, lower limit is 0. Upper limit is 0.015. The corresponding shaft as dimension is 9. That is limit is 0.001. Lower limit, the upper limit is 0.010. This is the limit of the shaft. This is the limit of the hole. So now need to find out when you are going to assemble it, what kind of fit it is come. That is we need. That's a very, very important. First thing is draw the line for the base value. What is the base value means? Here is basic value is 9. The basic value is 9 mm, or it is called nominal values. Now just draw the line. This is a 9 mm line. First take hole. What is the hole? Size is, first is the lower limit is 0. So it starts from here. The upper limit is 0.015 mm. Draw this upper limit. This value is what is 0.015. Okay. This is the limit of hole. Then draw the limit for shaft. Here we can start from here. First is what? 0.001 mm in plus. So first make a line like this. This is 0.001. Then upper limit is 0.010. Up to draw here. So this is for shaft, this is for hole. So now the both limit is in both limits are in overlappings. If the limits are come under the overlapping, the fit is called transition fit. The answer is C. So next problems, the hole of diameter 25. The limit is 0.020. Next limit is 0.040 mm or is assembled interchangeable with the pin of the diameter is 25. The limit is 0.008, the lower limit, upper limit 0.005. The minimum clearance in the assemble will be, we need to find out the value, minimum clearance of the assemble. First we have to draw the baseline. Draw the baseline for given value. What is this? Is 25 mm. First draw the hole. Hole is what is first started is 0.020 mm. So this is 0.020. Next is 0.040. 0.040 mm. This is the limit of the hole. Next, draw the diagram for the pin. Here, you start from minus 0.005. Here, what is this? Plus, this one is 0.008. Here, then is what is upper limit is 0.005. We have to draw here. This is one is 0.005. Okay. So now if you want to find out the clearance between the shaft and the hole, what is this here? This is the value is 0.020. This is above the base point. That is a base value. This what is some amount of this values above this basic value. What is 0.05? That is 0.05. So now we are putting this 0.05. What is the clearance is 0.015 mm. Okay, this is a way to find out the clearance between the hole and the shaft. Next question is here. The shaft diameter is 20 plus or minus values given. Then hole is diameter of 20 plus or in plus direction only given. Then when the assemble could be lies, we need to find out what kind of fit this. First, again we are going to draw this to find out the what kind of fit this. Okay, first draw the line for basic dimensions. 20 mm. First hole, what is the diameter of hole is 20. The plus is here 0.10. Next one is 20. This one is 0.20. Okay, this is a limit of the hole. Next we are going to draw the shaft. The shaft, how much this? Base is 20. The minus 0.15 here. The plus is 0.05 here. Okay. So now, how to find out this? We have the gap between the shaft and the hole. So it is obviously it is what clearance fit. The shaft can be the shaft can enter the hole easily without any struggle. So next, for the following hole and the shaft assemblies, determine the hole and shaft tolerance types of fit. Here the value is given. Hole is 20. The plus value is given the limit. First is 0.00, next 0.025, and the shaft 20, 0.005, 0.080. So now we need to find out the tolerance of hole and shaft and types of fit. Let us see how to find out the tolerance of hole and shaft and the types of fit. Here, same principle. So simple draw the line for basic dimension 20 mm. What is the dimensions of hole? Hole is 20. Lower limit is 0. Upper limit is 0.025. 0.025 and shaft is 0.05, 0.08. First draw this. How much this is? 0.025 for hole. Next, draw for the shaft. What is this? This is start from here. 0.05, then up to 0.08, 0.08 like this. What is 0.08 is more than as 0.02, clearly we see. Okay, so now let us tell me what kind of fit. Definitely where this is a transition fit, because the both values in overlapping, so it is called transition fit. Next, what is the tolerance? How to find out the tolerance? Tolerance is nothing, the difference between the lower limit and the upper limit. First let us see the tolerance of hole. Hole is the lower limit is 0, the upper limit is what is 0.025, the lower limit is 0.0000. So what is the tolerance of hole is 0.025 mm. Next, let us see this tolerance of shaft. Same principle. What is this? 0.08, 0.050, 0.075. What is the tolerance of shaft is 0.075. This is a method to find out what kind of fit and the tolerance of given assembly unit. So last problem is similar to the previous problems. Here the following limits are specified in the limit system to give the clearance between the hole and the shaft. This type of problems frequently asked in a gate examination. First thing is we need to find out basic size and the tolerance on shaft and hole, maximum and minimum clearance, then maximum material limit of the shaft. So first thing is, as what we have done in the previous problem, same things we are going to do. Take the 25 mm to draw the baseline. Okay, then is mark the limit. This lower limit is 0, the upper limit is 0.03. Okay, next shaft, the lower limit is 0.02. What is 0.02? Then upper limit is 0.06. So both are in a negative. 0.06. Okay, here we can find out this basic size easily. Nothing, basic size is a given dimension is a 25 mm. The tolerance on shaft and hole, yes, very easy. This is, what is the limit? 0.03, 0.000. The tolerance of hole, what is the tolerance of hole means 0.03. Then what is the tolerance of shaft? Very easy. So 0.020. Here what is 0.006? So 0.014. This is the tolerance of shaft. Okay. Then the maximum and minimum clearance. The maximum and minimum clearance, just we have to add the lower limit and upper limit. Here the upper of both is 0.03, here 0.06. So total 0.036 is the what is maximum clearance. The minimum clearance is, this one is 0.020. This is the minimum clearance. This one is a maximum clearance. This one is a minimum clearance. Next, the maximum material of hole and shaft. Hole and shaft, maximum material of hole is, what is up to this point. How much this? 25 mm. Maximum material of the shaft means how much? This. Total how much? This is a 25. So 25 0.0 minus 0.002. This is a subtract this 24.98. 24.98 is a shaft. Okay. Thank you very much for. I hope that you are understanding this. It's a great examinations. I hope you are successful in a examination presentation. Thank you very much.